Our vast universe is home to phenomena such as star-devouring black holes, rapidly rotating pulsars, radiant nebulae birthing stars, and countless galaxies. Yet it may not be endless. There could be a distinct edge, a cosmic boundary. Let's embark on a journey to that possible frontier. Visualize the universe as a massive layered structure. At its core is Earth, enveloped by our solar system, which is in turn housed inside a galaxy within this grand universe. As we journey beyond our solar system, passing by the planets from Mars to Neptune, we encounter the heliosphere. Here, the solar wind's velocity plunges dramatically, giving way to the near-stagnant wind at the heliopause. Beyond, the ship faces the force of the interstellar wind. Two remarkable emissaries from Earth, Voyager 1 and Voyager 2, now reside in this region. They revealed the heliosphere's uneven shape. Venturing further, an asteroid belt known as the Oort cloud becomes visible, believed by some scientists to source Earth-bound comets. Beyond lies the expansive Milky Way, spanning around 106,000 light-years. Guiding our journey is a cosmic map, identifying our location in the Laniakea supercluster. However, there's more. At a greater scale, the Hydra Centaurus supercluster emerges. At the universe's maximum observable scale, a surprising revelation awaits, evidence suggesting a universe boundary. This edge, located an astounding 10 billion light-years away, is a testament to time and evolution. During such a lengthy voyage, our sun might wither or explode, and the Milky Way might merge with the Andromeda Galaxy. Our endpoint is the Eridanus supervoid, a vast empty stretch spanning 1 billion light-years. This void might result from an unfathomable collision, our universe meeting another. This leads to a tantalizing notion of multiple universes, where every choice leads to alternate outcomes in parallel realities. Imagine our universe as a bubble. Eons ago, another bubble universe brushed against ours. Their gravitational interplay caused cosmic distortions. As they separated, a piece of our universe might have been taken, leading to the creation of the Eridanus supervoid. Eridanus supervoid covers a region of space about 1 billion light-years in size. This makes it one of the largest known voids in the universe. This superwave is associated with the so-called cold spot in the cosmic microwave background radiation. The temperature in this spot is lower than the average temperature of the background radiation. The exact origin and nature of Eridanus supervoid is still a subject of research. This object provides scientists with a unique opportunity to study the structure and evolution of the universe on large scales. Yet, perceiving the universe's entirety remains a challenge. Like an ant on a basketball, we see a consistent horizon due to our 3D viewpoint. But adding dimensions could change our perceptions. Could black holes, with their powerful gravitational influence, offer a passage to these other realms? The vast expanse of our universe is filled with intriguing structures, mysteries, and phenomena that continually challenge our understanding of the cosmos. The Eridanus supervoid, with its immense size and enigmatic nature, stands as a testament to the universe's capacity to astonish and confound us. And for those intrigued by the enigmatic nature of black holes, we invite you to explore more in our other videos. Dive deep into the mysteries of these cosmic giants and join us on a journey of understanding and wonder. Stop whatever you're doing for a moment and think about this. Where are we going? I don't only mean you or me. I mean our planet and the entire solar system. We've been traveling through space for eternity, but does this journey have any aim or destination? The solar system is moving at a speed of 450,000 miles per hour. Our beautiful blue Earth is snugly tucked inside it, and it seems that our region is quite calm and safe, not like some terrifying experiences our celestial neighbors go through. But where are we going? Just wandering around in a giant circle? Not really. Apparently, our galaxy, as well as several nearby galaxies, are being pulled toward a certain region of space. It's about 150 million light-years away. The worst thing is that we do not know what exactly it is. That's why we call it simply the Great Attractor. This bizarre area is, unfortunately, on the other side of the Milky Way. That's why we can't see it. This region of the sky is known as the Zone of Avoidance, and it's part of why the Great Attractor is so mysterious. This zone lies in the general direction of the center of our galaxy, and there's too much dust and gas there for us to see far in the visible spectrum. But astronomers can see enough to understand that our galaxy, as well as nearby galaxies, are all moving toward the Great Attractor. It means that something must be making things hurtle in that direction. Could it be a gargantuan black hole hidden in the darkness of the cosmos, pulling things toward it and munching on them? Or is it something even stranger and more dangerous? What we know for sure is that this something is immensely massive. For the first time, evidence of the existence of the Great Attractor was discovered in the 1970s. At that time, scientists didn't have the needed equipment to see through the zone of avoidance. That region blocks most of the visible light coming from beyond. But the good news is that this gas and light can't block all infrared and X-ray light. So when X-ray astronomy became more powerful, people got the opportunity to sneak a peek at objects dwelling in that region. It turned out there was a huge supercluster of galaxies in the region of the Great Attractor. It's now known as the Norma clusters. This enormous structure, consisting of thousands of galaxies, has a mass of around 1,000 trillion suns. So, the Norma cluster is massive, that's true, and local galaxies seem to be moving toward it. And still, it doesn't explain all the movements in that region. And now, I'll tell you something even more puzzling and spooky. The mass of the Great Attractor, whatever it is, isn't enough to account for the pull. If we take an even larger region of galaxies, it will become clear that both the Great Attractor and local galaxies are moving towards something even larger. This space behemoth is known as the Shapley supercluster. It's made up of more than 8,000 galaxies and is as massive as 10 million billion suns or even more. This supercluster is the greatest galaxy cluster we know about within 1 billion light years. And everything in the universe, Earth, the solar system, even the Great Attractor, are moving toward it. But at the moment, astronomers are still trying to find more information about the Great Attractor. The Hubble Space Telescope is now focused on the region of space where it resides. The largest galaxy visible in the region of the Norma cluster is ESO 137002. It's a spiral galaxy with large clouds of dust across the galaxy's bulge. Unfortunately, Hubble, being an optical telescope, can't see a tail of glowing X-rays extending out of the galaxy. And in general, observing the Great Attractor is difficult at optical wavelengths. The plane of the Milky Way both outshines and obscures with dust many objects located behind it. And even though we can get some information thanks to infrared or radio observations, the region behind the center of the Milky Way remains an almost complete mystery.
There are probably 36 other civilizations hanging out in the Milky Way, and over 170 billion galaxies, give or take, in the observable universe. Conditions for life are all over space. So, where is everybody? Nuclear physicist Enrico Fermi came up with this exact same question during a lunch break with his colleagues in 1950, leading to one of the most unsettling paradoxes in the universe. Even though there's a huge probability of extraterrestrial civilizations existing, we still haven't found any clear evidence of them. One possible explanation comes from the zoo hypothesis. It suggests that advanced extraterrestrial societies exist and know exactly who we are and where we are, but intentionally choose to stay hidden. They're just observing human quirky behaviors, as if we're in some kind of a cosmic wildlife park. But their intentions could be much darker. If you're a Star Trek fan, you probably remember the main rule for Federation members. Starfleet officers shouldn't contact species that are not advanced to avoid messing with their development, even if it means risking their own lives. Now, even though it's fiction, this rule perfectly captures what the zoo hypothesis is all about. Beings from other corners of the universe see our planet as a cosmic zoo with one-way bars. They can watch us brushing our teeth in the morning or walking our dog, but we can't catch a glimpse of them. In this theory, non-terrestrial life forms deliberately keep their distance from us, sticking to a hands-off policy agreement in the vast cosmic neighborhood. It's like those super smart beings agreed that we needed to have the freedom to shape our own future and destiny, following our own path of development without external contamination. The idea is that these super advanced civilizations could be like, 500 million years ahead of us, which would explain why we haven't seen any signs of them. And maybe it's better this way, as humans could eventually be destroyed or even assimilated by this new cosmic power, Independence Day style. As much as things like going to an art museum might be interesting to us, extraterrestrials probably wouldn't be too thrilled watching us stare at the Mona Lisa painting for hours. Interplanetary cultures might be more into buying tickets to quietly observe how we're developing new technologies, such as ultra-modern satellites. According to the zoo theory, they can't reach out to us until we hit a certain level of development. So improving our technology and wisdom could be the only way to show them that we're mature enough and don't need their spaceship parenting anymore. There are a couple of reasons why it's hard to buy into the zoo hypothesis. Extraterrestrials might not visit or reach out because we're not all that advanced. But it is tough to explain why they keep ignoring all our attempts to communicate. Even if the zookeepers try their best not to interfere with animals' lives and behaviors. I bet they couldn't just ignore a bear speaking in loud and clear English about its desire to communicate. So that's pretty much why humans keep trying and trying to provoke some reaction from inhabitants of other planets using radio signals. In 2017, in a valley 8 miles southeast of the Norwegian city of Tromsø, a radar antenna transmitted some specially composed electronic music to potential intergalactic listeners. The target audience was in GJ273, also known as Lyton Star. It's a runty red dwarf located 12 light-years from our solar system. Since radio waves travel at the speed of light, we'll have to wait more than 2 decades before looking for a reply. But the main problem with radio waves is that we're kind of in the dark about where to look, and civilizations might be as far as 17,000 light-years away. Plus, we don't know which radio frequency extraterrestrials use to chat. Now here on Earth, we use the radio spectrum to send signals into the universe, assuming that what works for us might be a common method for other civilizations. But in fact, it could be considered a somewhat old-school technique for other beings. That's why current projects are now looking for technosignatures, which are signs of technological activity from extraterrestrials, like city lights, solar panels, megastructures, or artificial satellites. Another potential clue is to study the atmospheres of planets orbiting nearby stars, as an advanced civilization might be altering its atmosphere with different gases, making it detectable. Despite decades of observations, there is still no definitive evidence that advanced extraterrestrial civilizations are out there. But that doesn't mean they don't exist. Even by expanding search fields, we're talking about odds much slimmer than hitting the jackpot, with a roughly 1 in 3 billion chance of finding an advanced civilization within a given distance from Earth. Maybe space creatures are responding to our communication attempts, but in a way that we can't understand. The universe has been around for more than 13 billion years, while humans showed up just 200,000 years ago. And this is about 0.01% of the universe's age. It's like we're still learning to talk, while other super smart beings might be sending us messages that are all lost in translation. We keep waiting for a giant UFO to land on Earth and for green ETs with huge eyes to come out of it. But we forget that our intergalactic neighbors could be more interesting in building nanotechnologies to watch over us. They could also be trying to communicate using neutrinos, which are subatomic particles with an extremely small mass that could effortlessly pass through our planet without being detected by our current technological devices. Now, the zoo hypothesis has another issue. It is pretty tough to believe that, with all these civilizations supposedly hanging out in the universe, they would all decide not to reach out to humans. For this to happen, there would have to be a great sense of structure, with a higher intelligence working as the head of the universe, giving them direct orders and clear rules to keep us isolated. But we're talking about billions of possibilities for life, right? More civilizations mean that there are more chances of a violation of this no-contact rule. So, most likely, at least one independent planet would be just as desperate to find life in the universe as we are. Some scientists also believe that if such advanced life had substantially colonized Earth and many other planets, we would know it by now. The zoo hypothesis has two other variations that are even more frightening. In the laboratory hypothesis, nobody contacts us because humankind is actually being subjected to experiments, and Earth is essentially a giant science lab. Otherworldly creatures could be analyzing human responses to various survival challenges, such as tsunamis or massive earthquakes. In this case, the no-contact agreement between all other space groups would make a bit more sense, since it's in the name of scientific research for the greater good, at least for them. The planetarium hypothesis, proposed in 2001, suggests that we are living in an artificial universe, in some kind of virtual reality designed to give us the illusion that the universe is empty when it's not. But no possible generator could test this hypothesis. Besides the zoo, the laboratory, and the planetarium theories, there is another possible answer to the Fermi paradox. Nobody contacts us because humans are completely alone in the universe. This is known as the rare Earth hypothesis, and it emphasizes how Earth occupies an incredibly unique position. No other planet could bring life to the universe that could be more than just bacteria. We may consider ourselves pretty lucky, as even a small change in any of Earth's orbital parameters, like the distance from the Earth to the Sun or the rate of rotation, could make conditions too extreme for people or life in general. But again, it's hard to think that we are alone in this vast universe. So, we're back to the paradox. Where is everybody?
According to the theory of panspermia, life could have been brought to Earth by a meteorite, comet, or asteroid from a different region of space. At the moment, this idea remains purely theoretical. But let's figure out if it could actually turn out to be true. Traditionally, exobiologists, those who are focused on searching for life outside Earth, have been trying to explore the possibility of life on Mars or in the subsurface oceans of Saturn's and Jupiter's icy moons. But simple life could be much more widespread. It could be drifting through interplanetary space right now, in the form of dormant bacteria and spores. Several scientists have noted that the ultra-harsh environment of space is likely to severely damage the DNA and RNA of such spores and microorganisms. Others believe that since enough microbes could be traveling in a dust cloud, some of them could survive in their original form. There are several types of panspermia. For example, lithopanspermia proposes that some kind of microbic life could exist in debris blasted into the cosmos after planetary collisions with comets and asteroids. Radiopanspermia claims that organisms might be able to travel through space with the help of radiation coming from stars. But in this case, it's unclear how the effect of dangerous ultraviolet and X-ray radiation, combined with the vacuum of space, doesn't totally destroy microorganisms. There's also pseudopanspermia. According to it, organic building blocks of life appear in interstellar clouds of dust. They get transported to the surfaces of planets, and life starts developing there. It sounds really fascinating, but is there any evidence for the panspermia theory? Well, there have been a few orbital experiments. For example, from 2008 to 2016, the samples gathered by EXPOSE, special equipment mounted outside the International Space Station and dedicated to astrobiology, were exposed to the conditions of space. After that, they were returned to Earth from the ISS. It turned out that some of them had survived those severe conditions. There was even a case when 100% of bacterial spores placed in Mars-like conditions were still capable of life. Also, some seeds survived and were later grown as plants on Earth. There have also been exostack experiments on the U.S. Long-Duration Exposure Facility satellite and biopan experiments on Russian photon capsules. They have shown that with minimal protection, spores, lichens, and even minuscule animals, such as tardigrades, might be able to survive in space for as long as several years. A piece of Surveyor 3 lunar lander was brought back to Earth in 1969 by the Apollo 12 mission. Shockingly, it contained an Earth bacterium that had survived unprotected for more than 2 years on the airless surface. At the same time, this bacterium could have come from laboratory contamination on arrival back on Earth. The Indian Space Research Organization carried out a search for space microorganisms too. It was done at stratospheric altitudes via balloon flights. The results showed that living interplanetary cells existed in air samples taken from heights of above 25 miles. Normally, air from lower levels of the atmosphere can't be transported there, so this discovery seemed to prove the theory of panspermia. But in 2010, NASA atmospheric sampling before and after hurricanes proved that under certain circumstances, Earth bacteria could actually be transported very high into the upper levels of the atmosphere. One of the main arguments against panspermia is that if this theory was correct, all life found throughout the solar system would have a common origin and share main biochemical characteristics like genetic code. It doesn't sound plausible. Many specialists believe that only the presence of astronaut explorers on the surfaces of, let's say, Mars, Europa, or Enceladus can properly solve the question of life in the solar system. They can compare any life forms found with Earth-type life, which can turn out to be a real test of panspermia. In any case, until probes finally find direct proof of spaceborne life, the panspermia theory will remain unproven.
The universe is believed to have started around 14 billion years ago with a Big Bang. And as far as we know, it hasn't stopped expanding since then. But if it's so, the universe must have started somewhere, right? And there has to be the center of the universe somewhere out there. Well, experts claim there's no center of the universe. Neither is there any center of the expansion. It's the same everywhere. You see, it's wrong to imagine the Big Bang as an ordinary explosion, and the universe does not expand from the center outward. Instead, as far as we know, the universe is expanding equally in all places. In 1929, Edwin Hubble said he had managed to measure the speed of galaxies that were located at different distances from Earth. He discovered that the farther they were, the faster they were moving away from us. Does it mean we are at the center of the expanding universe? Unlikely. It just means that the universe is expanding at the same rate everywhere. And wherever you are, it will seem to you that you're at the center of the universe. Now, about that Big Bang. If you watched a regular explosion in slow-mo, you'd see material expanding out from a central point. Right after the explosion, the center remains the hottest point. Later, a spherical shell of material starts growing, moving away from the center of the explosion. The process continues until gravity stops this expansion. But the Big Bang was nothing like that. It was an explosion of space, not an explosion in space. According to the most common theory, there was no before to speak of, no space and no time. It means that the Big Bang was very different from anything we're used to, and doesn't have any central point. Even if we had been able to observe it in real life, we wouldn't have seen an expanding edge with empty space beyond it. The only thing we can detect now is a faint background glow, It was left by the hot primordial gases that existed in the early universe. This is called cosmic background radiation, and it's uniform in all directions. It can mean only one thing. It's not matter moving outward from one point, but space itself expanding evenly. At the same time, the idea that the universe is expanding uniformly in all directions doesn't rule out the possibility that somewhere out there's a denser and hotter place that might be called the center of the universe. But as far as we can see, there's no sign of such a special point. The theory that the universe should be uniform is known as the cosmological principle. It appeared in 1933. Not so long before that, some scientists believed that the universe only consisted of our home galaxy. If this was the case, we could definitely consider the center of the Milky Way to be the center of the universe. But in 1924, Hubble put an end to that debate. He showed there were other galaxies besides our own. But in any case, how we see the universe is limited by the speed of light and the finite time since the Big Bang occurred. Even though the observable part of the universe is very large, it's likely tiny in comparison to the entire universe, which may be infinite. The universe might have many shapes, with or without an identifiable center. And if it turned out to have a center outside of the observable universe, this point, or region of space, could be just one of many. It could be just like the center of our galaxy, which was considered to be the center of the universe before.
A Dyson sphere is a theoretical megaproject, a ginormous sphere encircling a star with platforms orbiting in tight formation. It's supposed to be an ultimate solution both for energy production and living space. The creators of a Dyson sphere get a lot of surface area for habitation and the ability to catch every tiny bit of solar radiation and heat produced by their central star. The first person to theorize about such a bizarre construction was British-American theoretical physicist Freeman Dyson. According to him, an intelligent extraterrestrial civilization could consider building this sphere after colonizing some moons and planets in their local stellar neighborhood. With the growth of their population, these aliens would need more and more energy to sustain their lives. Dyson calculated that assuming that this alien society grew at 1% per year, their area and energy needs would become 1 trillion times larger in a mere 3,000 years. And if their solar system contained a space body similar in size to Jupiter, they could take it apart and spread its mass in a spherical shell by building a structure at twice the distance between our planet and the Sun. This amount of material would be sufficient to build a huge number of orbiting platforms. Each of them could be 6 to 10 feet thick, which would basically allow this civilization to live on their star-facing surfaces. A shell this thick could be comfortably habitable and capable of holding all the equipment needed for using solar radiation without falling onto the star from the inside. But after absorbing all this solar energy, the sphere would have to re-radiate it. Otherwise, the energy would build up, eventually causing the construction to melt. It means that the light of a star wrapped in a Dyson sphere would look dimmed or even completely darkened, depending on how dense the platforms orbiting it were. At the same time, it would glow unusually bright in infrared wavelengths invisible to the unaided eye. Because of this infrared radiation, Dyson spheres are classified as a type of technosignature. It's a sign of activity that astronomers can use to discover intelligent life forms in the universe. Some Earth-based researchers have infrared maps of the night sky they examine in hopes of spotting Dyson spheres. So far, no one has ever found one. However, one study has selected several Dyson sphere candidates. Its authors have processed large amounts of information using a special data pipeline for combining and analyzing information. One of the main search criteria is the detection of excessive infrared radiation. At the same time, it's important to distinguish this radiation from that emitted by natural objects. After a complicated filtering of millions of objects, the researchers identified 7 potential Dyson spheres. Sure, further analysis is needed to determine their nature. To do this, scientists want to use optical spectroscopy, which may reveal more details about these objects and their origins. At the same time, the researchers admit that these candidate Dyson spheres might have other explanations. For example, they could be debris disks or protoplanetary disks of young stars. Only more research can show whether we can find traces of other civilizations among star systems. For now, it's still an open question. Interestingly, Dyson spheres have been spoken about a lot in science fiction. As far back as 1937, a novel called Star Maker by Olaf Stapledon described systems in one particular galaxy that were surrounded by a gauze of light traps, which focused solar energy for intelligent use. That was the reason why the entire galaxy was dimmed. In another novel, Ring World, the writer spoke about a ring-shaped artificial structure surrounding a star.
If the multiverse theory is correct, ours is not the only one out there. Which is as interesting as it is scary, right? Now, not every scientist is on board with this mind-bending concept. And let's be honest, the idea of actually making contact with these parallel universes sounds about as probable as winning the lottery while riding a unicycle. But hold on tight, because this strange concept isn't just limited to the realms of fiction anymore. Believe it or not, a bunch of scientific theories actually support the existence of parallel universes. And let me tell you, it's a topic that stirs up quite the debate in scientific groups. Now picture this. The universe we live in is mind-numbingly vast. We're talking billions, some say even trillions of galaxies swirling around, each packed with an almost uncountable number of stars. Some brainiacs studying the universe's shape suggest that its diameter could span a staggering 7 billion light-years. Others even argue that it might be infinite. Could there be more out there than meets the eye? Well, real scientific theories are exploring the possibility of universes existing alongside, beyond, or even mirroring our own. These intriguing concepts of multiverses and parallel worlds often intertwine with other, more familiar scientific ideas like the Big Bang, string theory, and quantum mechanics. In order for us to figure out what's out there, we have to rely on the information we're a bit more confident in, right? Let's rewind the cosmic clock about 13.7 billion years ago. Everything we're able to see today was squished into a minuscule singularity. Then, if the Big Bang theory is to be trusted, it all went boom. The universe inflated with a speed faster than that of light everywhere, within less than a second. The way the universe went pop has led some clever researchers to ponder the existence of more than one universe. They question whether that sudden growth ended everywhere at the same time. While the expansion ceased for everything we're able to see from Earth 13.8 billion years ago, cosmic inflation might still be ongoing in some other mysterious corners. Some theoretical physicists say that as inflation ends in one place, a new balloon universe forms. But here's the catch: you can't just hop from one bubble to another like intergalactic tourists. These bubble universes are expanding indefinitely, and their edges are zooming away from us faster than light can travel. And here's where things get even more confusing. Let's say we somehow manage to reach the edge of our local balloon and encounter the next universe. Well, those same theoretical physicists mentioned that the neighboring universe could be a whole different ballgame. It might have completely different laws of physics, making it a bizarre place for us. Following the same idea, some say that in this vast multiverse of bubble universes, there might be other life forms just like us. The problem is, we're getting farther away from them with each passing moment, and our paths will never cross. Other super smart researchers out there are trying to connect parallel universes with quantum mechanics. Now, quantum mechanics is basically the fancy math behind teeny tiny particles. According to it, these particles can exist in multiple states all at once. They call it a wave function that holds all the crazy options. But here's the catch. When we observe these particles, we only see one outcome. It's like the universe keeps playing hide and seek with us. Now, there's this theory called the many worlds theory that says whenever we observe one outcome, another universe pops up where a different outcome becomes real. It's like our universe acts as a giant tree, constantly branching into countless versions of itself. These alternate universes can't mingle, though, so you wouldn't even know if there are a bunch of other yous living slightly or totally different lives. This many worlds theory is pretty bold and a bit hard to prove or disprove. And that's not great for science because scientists love to test and experiment with their ideas. But if there's infinite space out there, why wouldn't there be infinite universes too? Try to imagine the universe as this giant cosmic playground. Some specialists believe that if it's indeed never-ending, then there's only a limited number of ways that its building blocks can arrange themselves. Eventually, they have to repeat certain patterns. If this is true, then it may be possible that somewhere out there might be another version of you living the exact same life, even down to what you had for brunch yesterday. Did we ever have any proof of these supposed parallel universes? Well, some say we did. Have you heard the tale of the mysterious man from Taured? It's the story of a man that ended up at a Japanese airport saying he was from a totally unknown country called Taured. Now, some folks think it's proof of time travel, while others believe it's evidence he came from a different universe altogether. As much as you'd like to believe the story to be factual, the tricky part is this Taured place. There's a reason you haven't heard of it. There's no Taured to be found, whether in the present day or back in the 1950s when this supposed incident happened. After the airport incident, the man just vanished into thin air a day after arriving in Japan. Poof, gone forever. Let's rewind to that fateful day in July 1954 when the man from Taured supposedly landed in Tokyo. Descriptions paint him as a bearded, French-speaking man. Nothing too outlandish so far, right? Depending on who's telling the story, things start to diverge a bit. In one version, when the man hands over his passport to get stamped, the Japanese officer's eyes bulge out. While the passport looked legit, the country listed as Taured isn't recognized by anyone, including the officer and other officials. Naturally, they take our Taured visitor away for a little Q&A session. In another version, the man straight up tells the officer he's from Taured and shows him the passport when he doesn't buy it. Our man from Taured then started trying to convince the officers that his homeland is the real deal. According to him, Taured sat snugly between France and Spain and would have been around for about 1,000 years. To prove his point, he even points to the area on a map that matches the Principality of Andorra. Obviously, things took a mysterious turn. The officers decided to hold the man in custody, suspecting he might be up to no good. They put him up in a nearby hotel for the night, but not without stationing 2 people outside his room to keep an eye on things. Can you guess what happens next? Drumroll, please. When the officers showed up the next morning, ready to continue their investigation, the man had vanished without a trace. No sign of escape, and to make matters even more puzzling, all his personal documents have magically vanished too. What if the man from Taured was a time traveler or an intergalactic adventurer? Some have even delved into the realms of science fiction to explain this bizarre event, and you won't believe the number of people on the internet who've latched onto it as evidence for alternate realities. One of the weirdest ideas suggests that the man accidentally stumbled into a parallel dimension and ended up at the Japanese airport. In that parallel universe, there's an Earth just like ours, but instead of Andorra, they call it Taured over there. Another idea floating around was that the man was a time traveler from the future. Sorry to break it to you, but the most reasonable explanation for the whole story of the man from Taured is that someone's imagination went wild. Since there are many versions of the same story, it's probable people just kept adding outrageous details to the case, to make it more sensational. The whole story simply snowballed into an urban legend, and there's little to no reason to believe we've once seen a time traveler or intergalactic hitchhiker right here on Earth.
Even though it may seem that science has reached the level where there are no more mysteries left, it's not exactly true. And no modern physicist would dare to assume that our knowledge of the universe is near completion. What are scientists still wondering about? Let's figure it out. For one thing, dark energy keeps puzzling researchers even today. Because the universe doesn't seem to add up. Even though gravity is pulling space-time, the very fabric of the cosmos, inward, the universe keeps expanding outward, and this process is speeding up. That's how the concept of dark matter was born. It's believed to be some invisible agent that counteracts gravity by pushing space-time apart. It goes like this. The universe expands, and more space appears out there, and with it, more dark energy. According to astronomers, this invisible energy must make up more than 70% of the universe. But no one knows how or where to look for it. Then there's dark matter. You see, around 84% of matter in the universe doesn't emit or absorb light. Scientists call this stuff, which can neither be seen directly nor detected by indirect means, dark matter. Its existence is inferred from the effects it has on visible matter, radiation, and the very structure of the universe. There are a few special detectors on the lookout for weakly interacting massive particles, of which dark matter might be composed. But so far, nothing has been found. One of the most recent studies claims that dark matter might produce long, fine-grained streams radiating out from Earth like hairs and streaming throughout the universe. But it hasn't been proven yet. Then, there's the question of antimatter. It's the oppositely charged and oppositely spinning twin of good old matter. The intrigue here is why there is more matter than antimatter in our universe. It would be logical to assume that the universe would want to treat matter and antimatter equally. Thus, at the moment of the Big Bang, equal amounts of matter and antimatter should have been produced, right? Not really. If it had happened, there would have been a moment of total annihilation. Protons would have canceled antiprotons, electrons, anti-electrons, and so on. It would leave behind a lifeless, matterless expanse of space. Luckily, for some mysterious reason, when the universe was created, there was some excess matter. It didn't get annihilated, and that's how everything started. But there's still no accepted explanation for this. Then, we've got particle physics questions. They account for many unsolved problems. Sonoluminescence is one of them. Let me explain. Let's say you take some water and hit it with sound waves. It forms bubbles, low-pressure regions surrounded by high pressure. Once the outer pressure pushes on the lower pressure air, the bubbles collapse. But while collapsing, they emit light, even though the flashes don't last for more than a trillionth of a second. What bothers scientists is that it's unclear what the source of this light is. There are a few theories, of course. Some experts think tiny nuclear fusion reactions might be involved in the process. Others believe some kind of electrical discharge comes into play here. There's also the idea of compression heating of the gases inside the bubbles. None of these theories have been accepted yet. This might sound surprising, but we haven't figured out what exactly gravity is either. Other forces are mediated by particles, but not gravity. Some physical theories claim that it might be carried by a hypothetical massless particle called a graviton. But no one has seen these gravitons yet. We don't even know what kind of detector can be built to spot them. Even if gravitons come into contact with matter, and we aren't sure about it, they do it extremely rarely. There's also a theory that gravitons are closed loops of energy, but again, it's just a theory so far. There are tons of other unanswered questions bothering our minds. What happens inside a black hole? Is string theory correct? What is the fate of our universe? Do we live in a false vacuum? Hopefully one day we'll find the answers to all these mysteries.
Imagine living in a world where technology has reached its highest point. Your daily routines are orchestrated by an AI, which anticipates your every need, from brewing your morning coffee to selecting a perfect evening outfit. The cityscape outside the window of your floating home is a marvel of efficiency. Flying pods whisk people to their destinations. Renewable energy sources power the giant megacity, creating an environment of pristine streets and clean air. At work, you have online meetings with colleagues living across galaxies, collaborating on projects that go beyond our current understanding. It sounds like a sci-fi story, but some extraterrestrial civilization might have already reached this level of development. Scientists started pondering the possibility of life beyond Earth long ago. They've been wondering what such life could look like and how humans could identify it from afar. This train of thought led to the development of several classification systems, including one called the Kardashev scale. It was proposed in 1964. This classification evaluates hypothetical alien civilizations based on how much energy they are able to harness. According to the scale, there are 3 types of civilizations. The first type is a technological level close to the current level of Earth. Type 2 is a civilization capable of harnessing the energy emitted by its own star. And the third type is a civilization that has learned to use the energy of an entire galaxy. This scale sure caught people's imagination. It was included in a 5-page paper called Transmission of Information by Extraterrestrial Civilizations. This work focuses on calculating how powerful a light signal from any point of the universe should be for us to detect it. Now, within the basic categories, humans are a Type 1 civilization on the Kardashev scale. But some experts claim we aren't even a 1, since we haven't managed to harness the equivalent of the entire energy of Earth. This makes us more like 0.7, and of course, we're far from being a 2, a civilization with a working Dyson sphere. A Dyson sphere is a theoretical mega-engineering project encircling a star with platforms that are orbiting it in a tight formation. It might be the ultimate solution for living space and energy production. With its help, the creators of this ginormous construction could have loads of surface area for living and the ability to capture every tiny bit of solar radiation produced by their main star. As for a Type 3 civilization, it extracts fusion and exotic energy, information, and raw materials directly from their galaxy. This civilization is capable of space travel via wormholes, intergalactic communication via subspace, and galaxy-scale influence. They have supreme access to energy and are spread all over the universe. After millions of years of evolution, a Type 3 civilization may actually be AI superintelligences. Androids, cyborgs, and humans may be considered subspecies in such a highly advanced galactic society. In the most hopeful scenario, humans would have found a way to coexist with their AI masters. Or there might be no humans in that world whatsoever. This civilization might have already ascended into beings of pure energy, capable of controlling and directing machines to carry out all kinds of work. Now, back to the Kardashev scale. Even though it focuses only on technosignatures, it acknowledges biosignatures too, suggesting that each search should inform the other. The discovery of the simplest organism, for example, on one of Saturn's moons, could increase the probability that many Type 2 civilizations exist in our galaxy. At the moment, SETI is the main player in the field of looking for extraterrestrial civilizations. It's a combined effort of enthusiast scientists who focus on receiving and analyzing signals from space in the radio and visible light regions of the electromagnetic spectrum. It's looking for non-random patterns that have been likely sent deliberately by technologically advanced beings. The first modern SETI search was Project OMA in 1960. It used a radio telescope in Green Bank, Virginia. SETI uses targeted searches concentrating on groups of nearby sun-like stars.
We still can't find the source of the mysterious signal we've been receiving since 2018. We receive it every 22 minutes, and nothing can explain this. Some scientists even believe it could be coming from another civilization we haven't met yet. This strange radio signal wasn't found by a scientist on a serious mission. It was actually discovered by a college student just doing a regular project for school. Tyrone O'Doherty, an undergrad student at Curtin University in Australia, was sifting through old data of the southern sky. He was looking for any weird blinking radio signals. He finally stumbled upon one from 2018 that seemed to shoot radio waves towards Earth like a lighthouse beam. Excited about his find, Tyrone shared it with his mentor, radio astronomer Natasha Hurley-Walker. She dove into researching this signal, hoping for a breakthrough. But despite checking different frequency data, they hit a dead end. But then, Natasha spotted a pattern. The signal repeated every 18 minutes. This was huge. But just as they were gearing up to study it further, poof! The signal vanished after only 3 months, leaving them with nothing. Not giving up, Natasha and her team scanned the skies again, desperate for a clue. Months passed, but nothing turned up. They were ready to give up, and then suddenly, a new signal popped up. This one kept blinking for 5 minutes, then it disappeared. And then it came back exactly 22 minutes later. The main question was if that signal was related to an 18-minute one. To figure it out, Natasha went back to the old radio data from that area. As they dug deeper, they realized that, yes, and these signals aren't anything new. They'd been beaming towards Earth for 35 years. Back in 1988, Indian and American telescopes had caught them, but they got buried under tons of other data. This was great news for space explorers because it meant they could now calculate how far away this mysterious object was. After doing the math, they figured out it was incredibly far, even on a space scale, 15,000 light-years from Earth. Now, the only thing left to uncover was what exactly this object was. Walker and his team started comparing it to all the known radio-emitting objects out there. Yet its source remains a mystery. The signals still pop up every 22 minutes on NASA screens, always ending with a frustrating match not found message. The scientists called it J183910. Some think that the signal might come from some extraterrestrial beings. Maybe it's the signal that SETI, the search for extraterrestrial intelligence, has been waiting for. This project has been working for over 50 years, trying to find any evidence of life beyond Earth. They also scan the skies for radio waves, laser pulses, and other mysterious signals. So maybe it's a way for extraterrestrial folk to communicate their location. While that idea may sound exciting, we need to be careful about jumping to conclusions. First, we don't have solid proof for that. Before any concrete evidence, it's just speculation. And also, there are other more plausible explanations. Most likely it comes from a natural phenomenon, and there are a couple of theories for that. The first one is the pulsar theory. Imagine a huge star in space much bigger than our Sun. Sometimes these big stars finish their life journeys in a spectacular event called a supernova. When this happens, the star's core collapses, becoming super compact, as if you're squeezing all the stuff from that star into a tiny space. That tiny superdense core is called a neutron star. Some of these neutron stars are extra special. We call them pulsars. They get their name because they seem to pulse with energy, like a space lighthouse. These pulsars have incredibly strong magnetic fields, much stronger than what you'd find on Earth. They're like enormous magnets in space. Because of this, they shoot out beams of energy. They're also spinning super fast, so these beams of energy seem to pulse on and off as they spin around. Now, the strange signal we detected seems to have similarities with pulsars, but not quite. Pulsars usually have a predictable lifespan and slow down over time, eventually stopping their radio signals. In contrast, our mysterious signal is quite persistent and is blinking beyond what's expected for pulsars. So, maybe it's not a typical pulsar, or not a pulsar at all. There's also a magnetar theory. Now, a magnetar is another type of neutron star. They're like supercharged versions of pulsars, with even stronger magnetic fields and slightly longer pulsating periods. Maybe this is what causes our signal's intense persistence. However, when we plotted the data, we also realized the signal didn't match the magnetar's vibes either. Magnetars not only send out radio waves, but also powerful X-rays because they're so energetic. But the signal we received was only sending out radio waves. So we figured it's not a pulsar and not a magnetar. The signal's behavior is very strange and suggests an unnatural source. This means there might be something in the universe that scientists haven't fully explored yet. And there is a space object that we don't know much about. The final theory is the so-called dwarf pulsar. Sounds a little dopey to me. Couldn't help myself. Now, a dwarf pulsar is like a star that blinks with light flashes, similar to pulsars, but it takes longer for each blink. Usually, white dwarfs are the leftovers from smaller stars. They don't blink because their magnetic field isn't as strong as pulsars. But when a white dwarf becomes pretty hefty, almost the mass of our Sun, it gets super dense and starts pulsating with a strong magnetic field, just like pulsars. They have a cool quirk. White dwarfs are made of electrons, not neutrons like pulsars. When these charged electrons start dancing with the magnetic field, they shoot out periodic light flashes, which happen every 100 to 1,000 seconds. As you remember, our signal has a period of 22 minutes, 1,320 seconds. A bit longer than the usual white dwarf pulsars, but it's much closer to the truth. So far, this sounds like the most plausible explanation. But even this theory isn't fully confirmed yet. This just shows how much there is in the universe that we're still figuring out. For example, fast radio bursts, another mysterious type of signal we've been detecting. They're like quick, intense bursts of energy in the form of radio waves. They have a ton of energy. FRBs are so powerful that sometimes they can be brighter than entire galaxies. Now, imagine this. They release as much energy in a few milliseconds as our Sun does in 3 whole days. Wow! These bursts happen all over the sky with huge frequencies, although some have been detected with lower frequencies. Every day, we catch around 10,000 random FRBs in the sky. Some of them repeat, but most happen once and disappear forever. Unfortunately, most of them only last for a fraction of a second, and by the time their energy reaches us, it's 1,000 times weaker than a mobile phone signal from the moon. This is why, despite their brightness, there's still a lot we don't understand about them. We're still trying to figure out what causes these FRBs. They could be coming from different sources, like already mentioned magnetars, colliding stars, or even merging galaxies or white dwarfs. As these bursts travel through space, they pick up information about the cosmic environments they pass through, like interstellar gas clouds. It's very unlikely that FRBs are some messages from extraterrestrial beings, though. Not only because there are thousands of them every day all across the sky, but also because we know that the sources of these bursts must be incredibly energetic themselves. Our neighbors would have to have equipment stronger than entire galaxies for that. But the bottom line is, while all these signals are fascinating, there's still a ton to learn about them.
How about going deep, deep into the past? To the times before humans existed, before the infamous asteroid hit Earth, wiping off 3/4 of life forms on the planet, even before the sun ignited or galaxies appeared in the darkness of the cosmos. So, before light could even shine, there was the Big Bang. It happened 13.8 billion years ago. But what was before that? Some scientists are sure that there was no before. Time started ticking as soon as the Big Bang occurred. We're unlikely to ever figure out what reality was like before that, if any. This is beyond human understanding. But there are those who disagree. Some unconventional scientists theorize that just a moment before the Big Bang, all the energy and mass of the nascent universe could be compacted into an insanely dense but still finite speck. Let's imagine it as a seed of a new universe. And this seed, a chunk of essential material, compressed and hidden in a protective shell, was created nowhere else but inside a black hole. Black holes spin incredibly fast, probably close to the speed of light. Such a spin can give the tightly compacted seed a ginormous amount of torsion. So the seed isn't just tiny and extra heavy, it's also compressed and twisted, which means that it can suddenly unspring with a big bang. Now, let's say you add up the energy and mass of all the particles the visible universe contains. And then you try to figure out the answer to the following question. How big could the event horizon of a black hole with the same mass be? The event horizon is the point of no return. Once you cross this invisible line, there's no way back, even for light. But let's get back to our question. Shockingly, such an event horizon would be very close in size to the actual horizon of the observable universe. There's also this idea that became well known thanks to Stephen Hawking. According to it, every time a black hole appears in our universe, it probably gives rise to a baby universe. but you would only be able to visit such a universe if you crossed the event horizon and plunged inside the black hole. And as you know, once you did it, you wouldn't be able to return. In other words, right now, we might be living in a baby universe. But if some outsider is observing us at the moment, our world looks to them like a regular black hole. So in short, there could be a very old mother universe that forged a seed inside a black hole. This seed had its big bounce all those billions of years ago, and as a result, our universe came into existence. But even though since then it has kept growing and expanding, we might still be hidden behind the event horizon of our home black hole. There's also another idea. According to string theory, there's a multiverse of universes. Imagine our universe as a soap bubble. This bubble keeps expanding, and we live on its surface. String theory claims that our bubble isn't unique. There might be other bubbles out there, and all these bubbles move around, collide, sprout, or bud baby bubbles. In short, live their life. If we follow this theory, we might suppose that black holes are one-way doors between universes. And if you accidentally tumbled down the black hole in our home Milky Way galaxy, you'd end up in another universe. Or rather, not you, but what's left of you after falling through the insane weirdness of the black hole. In this case, this second universe wouldn't be inside ours. It would exist separately, and the black hole would merely be the link connecting them, like a shared route between two aspen trees. Whatever the truth, the danger is still there, lurking in the shadows. What if the black hole we live in decides to collapse? What if it pulls us deeper inside? Or if our world is just a bubble among trillions of other bubbles? What if it bursts one day? We've never sneaked a peek beyond the edge of the observable universe. What lies there? If we managed to get there, would we find another universe? What if the universe we live in is just one of billions of trillions of other universes? I'm talking about the concept of a multiverse now. Look, there's this idea of parallel universes. Let's take one of them. It looks exactly the same as our universe, and still, some details differ. Maybe instead of becoming a doctor, you chose to start a music band there. Maybe one infamous asteroid changed its trajectory, and dinos are still roaming Earth in that universe. But the multiverse theory takes it all one step further. Those who believe in it state that there might be countless realities. According to this theory, we live in a bubble that is just one of many other bubbles, which I guess looks like bath foam. These bubbles constantly bob up and vanish. Multiverses are described by a few scientific theories, which mention various possible scenarios, from separate universes that keep springing into existence all the time, to regions of space that are in different planes than our home universe. But there's one thing these theories agree upon. All of them suggest that the space and time we observe is not the only reality. You see, it's impossible to explain all the quirks of our universe if it's the only one to exist. So it's either inventing newer theories that can throw light on certain properties of our universe, or accepting the fact that we're living in just one of many, many universes, all of which are different. One of the most widely known multiverse theories is called inflationary cosmology. This is the idea that right after the Big Bang, the universe expanded rapidly and exponentially. Indeed, cosmic inflation does explain lots of the properties of the universe we observe. For example, the distribution of galaxies. When this theory was suggested for the first time, it was perceived as a piece of science fiction. But it can indeed explain tons of interesting features of the world we live in. So with time, people started taking it seriously. Now, the theory states that inflation might happen again and again, maybe even infinitely. And this could create constellations of bubble universes. Of course, none of these bubbles will have the same properties as ours. There may easily be places where physics as we know it doesn't exist. But even though some of these universes might look like ours, they all lie beyond the realm we can observe directly. Another theory, called the many worlds interpretation, claims that there might be multiple branching timelines, or alternative realities. And in each of those realities, our decisions play out differently, which also means very different outcomes. At the same time, the only reality you can perceive is the one where you live. If it's true, then the question is, where are all those other universes? Well, they most likely all overlap in dimensions we absolutely can't access. And at the moment, it's not possible to travel between universes. But who knows? Maybe a few thousand years later, people will not only find a way to prove that parallel universes exist, but also invent a method to hop from one of them to another. Unfortunately, so far, there's no solid evidence that multiverses exist. All the proof we've got today is purely theoretical. Some experts even argue that it could be an unbelievable cosmic coincidence that the Big Bang created such a perfectly balanced universe as ours. Or, if parallel universes do exist, we might have just inhabited the one that had all the right conditions for our survival. It's still unclear whether the multiverse theory is even testable. Perhaps we just haven't thought of the right tests yet. Now, I've got one scary thought for you to consider. What if, at one point, you stopped existing in your home universe, the one you were born into? What if your consciousness was transported to a parallel universe, where you're now watching this video? Think of this.
Dozens of spacecraft and hundreds of probes take off from Earth and head for our planet's twin sister, Venus. It's about the same size as the Earth and has around 80% of our planet's mass. The temperatures here are too high for humans, and it doesn't have the air we're used to breathing. But we went there because scientists recently found traces of phosphine gas, which suggests that life might be there. Phosphine comes from various microbes and bacteria, so humanity goes on this journey to discover this life. With our technology, a flight to Venus would take 3.5 to 6.5 months, but we finally made it. Spaceships are landing on the planet, and when the first humans come to the surface, they see heat-scorched deserts, lava lakes, and geysers of poisonous acid. And that's it. Scientists miscalculated the radio telescope data. Phosphine never existed on Venus. So we're going back to the rockets, and we're getting ready for a longer trip across our galaxy. The scientists believe that there's at least 36 civilizations in the Milky Way that are similar to ours. They could be living organisms completely different from us. They may have different bodies, different eyes. They may walk and talk in a very different way than we do. But an advanced civilization has several criteria: technological progress and the use of developed communication between individuals. So, these civilizations must explore space, build cities, and be able to communicate with each other as independent species. Let's look at our galaxy and find these civilized worlds. So, the Milky Way is a spiral of 100,000 light years from side to side. If a star is born at one end of it in a super powerful blast, the light from that event won't even reach the other end until 100,000 years later. There's about 100 billion stars, and near each of them, there may be worlds similar to our solar system. Let's try to find these habitable worlds using giant sieves. First, we look for stars that have a lot of iron. Such stars burn at the perfect temperature for the development of life. And the iron in the star system will help form the cores of planets that will be home to another civilization. We sift the Milky Way through our sieve. We see that there are too many stars that fit the description, so we need another filter. Now let's find stars that look like the Sun in this pile. The star must be about 100 times larger than the Earth and 333,000 times heavier. An important criterion is the age of the star. When a star gets old, it begins to expand and turns into a red giant. At this time, it can absorb the planets around it. The life of such a star can end with a huge blast that destroys everything around it. So the star we're looking for must be relatively young. Let's use our sieve again. There's fewer stars, but still that's a lot. Now let's focus on the planets. They should be in the habitable zone of the star. Not too close to a star because then the temperature would be too high for life to be born. And not too far away. Then the planet would just be an ice block with nothing living on it. The temperature of the planet must allow the water to remain liquid. Another filter is the age of the candidate planet. It takes time for an advanced civilization to develop. Based on the experience of Earth, scientists believe that it takes at least 4.5 billion years for any life form to evolve to the human level. So we're looking for planets similar to Earth or older. We use our sieve one last time, and voila, we have 36 worlds where an advanced civilization is possible. Scientists conducted this study and published it in April 2020, based on these very criteria. All that's left is to discover these civilizations and make the first contact. We can detect such a civilization by using radio waves that come from it. Suppose there's a planet A with primitive living organisms on it. Millions of years of evolution, and they'll become a civilization with advanced technology. Radio waves will be the way they communicate. Then the whole planet will emit radio waves like a star emits light. And here on Earth, we'll be able to pick up this signal with antennas pointed into space. But there's a problem with the distance between the planets. For example, Planet A is 1,000 light-years away from the Earth. When Planet A starts emitting radio waves, these signals won't reach us until 10 centuries later. We learned to emit and receive radio waves in 1895. And if the civilization on Planet A emitted a radio signal at the same time, we won't be able to pick up that signal until 2895. It'll be the same on Planet A. We sent a message in the form of a radio signal into space in 1974. In this signal, we encoded our number system, human DNA, and information about our solar system. If there's an advanced civilization on Planet A, they'll be able to receive this signal only in 2974, and we'd have to wait another millennium to get a response from them. Another problem with radio waves is that they don't look like a constant glow on the planet, but like a flare. Radio waves are only used at a certain stage of civilization. At first, it's the primary method of communication, but then we begin to use cell phones, cable TV, and fiber optics. And as technology advances further, our radio wave light begins to fade out. So we only have about 100 years of active radio use by civilization to find it. One day we caught a strange radio signal of an unknown origin. Its characteristics suggested that the signal was created artificially, perhaps by an outer space civilization or a passing starship. Further searches for this signal given no results, and this gave rise to many theories and arguments as to what it really was. It could have been a signal from Earth that reflected off a satellite flying through the sky, or it could have been the traces of a comet a few light years away. But let's assume it was a civilization from outer space, one of those 36 that probably exist. Now we need to make contact with them. So we throw our luggage into a rocket and head out in the direction of our suspected planet. Our rockets can fly at 17,600 miles per hour. That means a rocket could cross the entire United States in just 8 minutes. But even if an advanced civilization lived near our closest star, Proxima Centauri, it would take us about 73,000 years to get there. Even at the speed of light, it would take 4.2 years. So we need to solve the problem of space travel. Our scientists plan to reach about a quarter of the speed of light with a laser. A powerful laser beam from Earth will push a microscopic probe in the right direction. This probe could reach our destination in about 17 years. And in another 4 years, when the signal from it reaches Earth, we'll know if there's an advanced civilization. Another possibility for faster-than-light travel is the warp bubble spacecraft. The spacecraft would have to compress space in front of it and stretch it behind its tail. Then we'll be able to reach any point in the universe in literally a few seconds. But such travel remains a fantasy for us. Perhaps we can get to different corners of the universe through wormholes. They're shortcuts similar to tunnels, but there's one problem. These wormholes might be inside black holes. They're the most mysterious objects in the universe. They're so heavy that even light can't escape their trap. Our spaceships wouldn't stand the tension either. There's also a theory that Earth is unique because it was born under completely accidental circumstances. 4.5 billion years ago, our planet was a block of lava that began to cool and solidify, but its tranquility was broken by an asteroid the size of an entire planet flying by. The collision occurred at such an angle that the Earth was not completely destroyed, but part of the asteroid remained in our orbit. A heavy rock near our planet stabilized Earth's rotation, and the gravitational interaction with the giant debris caused our core to heat up. In addition, the asteroid brought a lot of water to Earth. Such a collision is extremely unlikely. It's like winning the lottery, many times in a row. But so far, we have no reason to believe life in outer space exists. Just as we have no reason to believe that there's no advanced civilizations in the universe, except for ours.
You're driving to your sister's house when all of a sudden the sky changes. The cool weather becomes scorching hot in a matter of minutes. People who were going for casual autumn strolls have now taken off their jackets and are sweating. People who were planning on going for a weekend ski trip have canceled their plans at the last minute to head to the beach. It was sunset, but the sky has become as bright as day. You fish out your sunglasses and continue driving. Nothing seems normal, but people don't seem to care. You put on the radio and hear everyone panicking about the sun. Nothing is cohesive. They're jumbling up their words and saying a gazillion things at the same time. You take out your phone and see what's happening on social media, and it's all the same thing. Nothing is comprehensible. It's just people talking about how the sun is getting closer to the earth.
Footsteps are clacking along a quiet hallway. A man dressed in a sharp suit is making his way to one of the most important meetings of his life. Adam walks through the meeting room while everyone is waiting to hear what he has to say. As the head astrophysicist, it's Adam's responsibility to figure out what is happening and not let the public know what's going on. Otherwise, the whole world will succumb to panic and mass hysteria, which won't be good. He takes a seat at the head of the table while everyone waits for what he has to say. The room is tense and no one is saying a word. He takes off his glasses and places them on the table. Everyone is watching his every move. He takes a few files out of his folder and starts reading. His voice can command a room. My fellow colleagues, I'm afraid the worst has fallen on us. After countless hours of consistent observation and analysis, we have discovered that a piece of the sun has abandoned its orbit and it's making its way toward us. We still don't know which part of the sun, but we know that once it strikes us, we may not have an Earth to call home any longer. The tension in the room is palpable. Everyone looks at each other confused. Adam answers as many questions as he can, but he himself doesn't even have some of the answers. In a matter of minutes, the press leaks some voice recording of Adam's speech, and the world goes berserk. Back to you. You just heard a snippet from Adam's speech and aren't too convinced of its validity. Even though the sky is getting brighter by the second, there's still no reason to panic. You continue driving, and suddenly you sense an intense vibration. Your car lifts off the ground and the windows shatter. You get out and duck for cover. You saw a comet-like object strike down in the middle of nowhere, miles away. More of these objects look like they're heading toward the ground. You start your car and drive off, trying to find a place to hide. Ashes start covering the sky, which makes it even hotter than it already is. The earth is scorching. Meanwhile, traffic is piling up for people who want to escape but don't have any real place to hide. You eventually abandon your car and go on foot, trying to find a place to cool down and get away from the sun's rays. Even though ash is covering the sky, the sun is still blasting through it. You head to the woods and find a cave to cool down in. It's still hot, but at least you can calm down and figure out your next move from there. You get out your phone and try to see if there's any news updates on what's happening, but nothing seems to be updating. You keep refreshing it, but nothing works. Suddenly, you hear some people getting closer, and they order you to step outside of the cave. Adam is with the top scientists in the world, trying to figure out a solution. Everyone is presenting him with solutions, but in the end, none of them are achievable. They've spent hours in the office, but with each passing minute, the sun is getting stronger and the sky is getting brighter. It feels like nothing can be done until Adam has an aha moment. He calls for everyone's attention and asks for the extra people who are not contributing to leave the room. He mentions that they need to launch a rocket into space that can divert the large mass heading toward the Earth before it breaches the atmosphere. They only have a few hours before the sky becomes completely dangerous and unsuitable for flying. As for now, all flights around the world have been canceled. There is only a small window of opportunity to get this rocket out there and save the world. Adam summons the best engineers he can find to adjust the rocket and the astronauts who will volunteer for the mission. They go into quick basic training and start planning for the next steps. After many briefings, they're ready, but they only have one shot at diverting the large object. The astronauts are ready and begin to enter the rocket. Suddenly, you pop up out of nowhere, dressed in a spacesuit. You're one of the prominent astronauts for the mission. Those people who found you in the cave were from NASA, trying to recruit you for the mission. You meet with Adam, and he quickly briefs you about your role. Because the mission is very last minute, there wasn't even time for Adam to sit with you and give you the proper training or brief. You enter the rocket and take your seat. The engineers and scientists gather around to make sure that everything is in order before takeoff. The large object is getting closer, and if the rocket is delayed, then it'll melt when it reaches the final part of the mission. You're strapped in and the rocket starts rattling. All systems are in order. 3, 2, 1, blast off. The rocket picks up and shoots into the sky. There are extra layers of visor shield protection, since it feels like you're getting closer to the sun. After a few minutes, the rocket leaves the Earth's atmosphere and is at the forefront of the large object. The rocket suspends itself in a certain strategic position, waiting for the right time to swat the object out of the Earth's trajectory. Meanwhile, everyone back on Earth is hiding in bunkers when the loose debris strikes. A cleanup team will be ready to get rid of the space rocks that will be scorching hot. The bunkers are equipped with food, water, and electricity in case they have to remain underground for a while. Only a few minutes left until the moment comes. You press a button and get ready to deploy a large spike that's as long as the Statue of Liberty. The spike is kept on a stand that's attached to the rocket. It will fire the spike like a bow and arrow and shoot it straight through the large object, breaking it before it melts. There's less than 1 minute before impact. The arrow is stretched and released. The tip of the arrow has a titanium drill that will continue drilling through the object as soon as it hits. The arrow is released and shoots through space, breaking little pieces of space objects along the way. As it speeds through, it finally hits the large object and drills through it. But nothing seems to be happening. The drill is barely getting through the center. Luckily, Adam had already thought of a backup plan. The rocket, still suspended in its spot, fires a laser where the spike is to speed things up. The laser starts melting through to get to the core. The object is getting closer and is speeding up. The object still hasn't broken into pieces yet. Less than 2 minutes until impact, and everyone is running out of options. Adam has one last trick up his sleeve. He orders everyone to evacuate the rocket and move to the backup pods. He wants to put the rocket on a straight collision course with the large object. There's too much confusion. Everyone, including you, quickly heads to the pods and ejects to a safe distance. These pods won't float around in space since they have pressurized air that allows the pods to move in whatever direction the driver wants. Everyone shoots out of the rocket while it goes full speed at the object. They're both going, heading for each other at full speed. There are only a few seconds until impact. The whole world is watching. This rocket is now the only hope there is to save everyone on Earth. The rocket starts melting before impact, and suddenly, a large shockwave ripples through the sky. The rocket was able to break the large object into many pieces. The problem now is the smaller debris falling onto Earth. But since everyone is in bunkers, they're safe. Adam and his colleagues celebrate. You and the rest of the astronauts are safe and make it safely back to Earth. The next phase for everyone on Earth is to rebuild everything that was destroyed. People will have to start everything from scratch, but this is only the beginning of a new chapter in life.
Space, the final frontier. It's a vast and mysterious expanse that has fascinated us for centuries. But as much as we've learned about it, there are still plenty of things that we've been lied to about when it comes to space. Let's take a look at some of the biggest lies we've been told about this topic. First off, we have the idea that space is just this pristine, untouched wilderness. But that's not exactly true. We've been littering space with our debris for decades. Everything from old satellites to rocket parts. In fact, there are over 20,000 pieces of debris orbiting Earth right now, and they're causing all sorts of problems for future space missions. So if you're planning on visiting space anytime soon, watch where you go. You never know what kind of garbage might be floating around. Did you know that the sun is not actually yellow? It's green. Well, kind of. You see, scientists measure the temperature of a star by the color spectrum it emits. Cooler stars appear red, while the hottest of stars look blue. Our sun emits most of its energy at a wavelength that's close to green. But because it emits other wavelengths too, all these colors mix together, and your eyes see this vibrant mixture as white. From Earth, however, the sun looks yellow because our atmosphere is really good at scattering blue light. If our star was actually yellow, Earth would become a frozen rock, and we'd all be polar bears. Plus, the sun isn't on fire for real. It's a big ball of gas, mostly made of hydrogen and helium, and it works more like a gigantic nuclear reactor. constantly fusing hydrogen atoms to create helium inside its core. This process releases enormous amounts of energy. That's why the sun is so hot. Oh, and speaking of setting things on fire, explosions in space aren't real. Sorry, Star Wars fans, a spaceship can't go down in a violent blast because there is no air out there in space. No air means no oxygen, and no oxygen means no fire. Now, you might also think that there are too many stars in the night sky for you to count, but in fact, you can do that. According to the Yale Bright Star Catalog, there are 9,110 stars that you can see from Earth with the unaided eye. So, technically, you can count them, but I wouldn't be surprised if you lost count. And if you're worried about flying through an asteroid belt, don't be. Although it does have trillions of space rocks that range in size from space dust to a quarter of the size of the Moon, they're very spread out. The asteroid belt between Mars and Jupiter is 140 million miles across, which is 1.5 times the distance between Earth and the Sun. This spreads space rocks thousands of miles apart, making it almost impossible for a spacecraft to collide with one. You'll instantly freeze in space without a suit. Nope, you won't turn into a popsicle right away. It's going to take a bit longer than that because heat and cold don't really move very quickly in the vacuum of space. But unfortunately for you, there's a bigger problem at hand. You won't be able to breathe. After just 15 seconds, your brain won't be getting enough oxygen from your blood, and you'll pass out. And then after just 2 minutes, it's curtains for the rest of your organs. So, in short, if you find yourself playing astronaut without a spacesuit, it's game over pretty quickly. Did you know that space doesn't have any temperature at all? That's because the temperature is defined by the speed at which particles move and the amount of energy they have. In the true vacuum of space, there are no particles to move around, making it temperatureless. Of course, some parts of space are really hot, like areas around stars. But the further away you get from stars, the more spread out particles are, making those areas of space pretty chilly. Number 9 is our planet's shape. No, it's not flat, but it's not a perfect sphere either. Yeah, it bulges at the equator because of our planet's wild spin. It's like Earth is doing its own little dance. And because of this bulging, launching spaceships from the equator is much easier than from the poles. Now, when it comes to sound in space, it's a bit of a tricky situation. You might think that no one can hear you scream, but that's not entirely accurate. The thing is, sound needs something to travel through, like air or water. In space, things are super spread out, so all those epic space battles and galactic explosions would be completely silent. Yet there are some places in space with enough particles for sound to travel through. For example, you can hear the black hole at the center of the Perseus galaxy cluster. Another myth is about zero gravity. That's not a thing. There's still some gravity hanging around the International Space Station, about 90% of what we feel on good old Earth. But astronauts get to float around because they're basically free-falling around the planet. And let's be real, Hollywood's version of space travel is not factual. Sure, orbits are a thing, but different altitudes mean different speeds. So moving from one orbit to another isn't exactly a walk in the park. You can't just push yourself in the right direction and hope for the best. You gotta take those orbital velocities into account. This reminded me of the 2013 movie Gravity and how Sandra Bullock tried to survive in space. Hollywood sure added some fuel to these myths. Yet again, who can blame them? Back in 1976, NASA's Viking 1 spacecraft snapped a photo of a curious rock formation on Mars that looked suspiciously like a face. Some folks out there claimed that it must have been proof of extraterrestrial life on the red planet, but NASA had a different take. According to the space agency, the face was nothing more than a bunch of rocks piled up in such a way that the shadows they cast created an illusion of facial features. It turns out it was just a regular hill that got a little too much credit for being photogenic. the solar system stays in place. Lie! It's zooming through space at a speed of 140 miles per second, which means that it's whizzing through the cosmos faster than a cheetah chasing its prey. It takes us 230 million years for the solar system to complete a full orbit around the Milky Way. It's a good thing it isn't getting a speeding ticket, because that would be one astronomical fine. Eh? Without the sun, planets would be pretty chilly. We're talking about temperatures as low as -455 degrees Fahrenheit. Brrr. But with the sun around, the planets get to enjoy much more livable temperatures. Of course, not all planets are created equal. Mercury, for example, is the closest to the sun. Venus, on the other hand, is farther away, but somehow manages to be even hotter than Mercury. The distance from the sun isn't the only factor that affects a planet's temperature. Other things like the planet's size and reflectivity also come into play. So Mercury being the hottest planet in our solar system is a false proposition. No, just because it's the closest one to the sun doesn't mean it's the hottest. Even though we've been deceived in some ways, that doesn't make space any less amazing. It's still a vast, beautiful, and utterly fascinating part of our universe. And there's still so much we have yet to discover. Who knows? Maybe one day we'll really discover little green people out there. Or maybe we'll find out something even more incredible. Until then, we'll just have to keep dreaming and exploring. There, you got 14 things on our list. Do you have any other space myths to debunk?